Hello, everybody, and welcome back. Thanks for tuning in to another episode in the series. In the last episode, we left off with just finishing up the entity implementation and the app database implementation, but I've actually gone ahead and kind of updated some things behind the scenes here to just help us along because I didn't want to, drag you through some of the boilerplate code here, but I'll just give a brief overview of what I've done so far. If we just take a look at the package structure, we've kind of structured things a little bit differently. So we have a database structure or a database package, and then the appropriate sub packages within that. Little UI home package. Created a base fragment here, or I don't remember if we created it in the last episode or not, but kind of modified it and built out some more helper functions or helper methods that we'll end up using in our implementation fragments. And this one here, I kind of want to note, changed how to get the actual app database. We had it before in the main activity in a by lazy function here, as you can see defined. But we're going to want this, I guess, just accessible in more places than just in the main activity. So I figured we can go ahead and actually create a static function to get the database on the app database class itself, which holds a reference to the database initialized to null originally. If it is not null, we return that database. Otherwise, we actually go ahead and just build the database. And then here we have our item entity DAO set up. And I believe I also modified a handful of the dependencies here. So we had the room one, but we've also added the navigation components and the epoxy libraries to this project. If you are not familiar with either of these, we've covered them pretty much in depth over the last 2 seasons, I believe it is. So go ahead and feel free to peruse through some of the content there if you are not already caught up to speed on that. But specifically around the navigation components, we had to kind of change some things architecturally. So we've created our nav graph here that exists in our navigation directory, created a fragment for the home fragment that I've created so far. Let's see, the main activity has been updated to have the fragment container view as we would expect for this kind of navigation. And then we have a very basic fragment home here, which literally has nothing in it. So I guess this is a pretty good spot to kind of pick up. And the idea is that we're going to have a main screen of items, if you will, that are basically things that we need to buy, or a little, like, a running shopping list is, I guess, the best way to think about it. So in order to actually go ahead and draw those on screen at the fragment level, we're going to have the epoxy recycler view. We're just going to set this to match. Call this the epoxy recycler view. We're going to give it the orientation of vertical and a layout manager of linear for now is fine. Yeah, so I think that's about it for now. That's what we need. And then we're going to have to go ahead and kind of set up our architecture here a little bit. So I just want to think of the best way to structure this in the packages here. Make an arch package and create our 2 by view model here, and then our 2 by repository as well. So here we're going to actually interact with our database, and inside of our view model we are going to I guess interact with the data we get from our database, and then also like the middle layer between our fragment and the repository to add in our or make modifications or read from the database. So if we take a look at the DAO here, which I'm going to split for us, Nope, don't need that. Just looking for the repository here. So we have three functions defined here at the moment: to get all, insert a particular one, and delete an item entity. So in order to actually go ahead and interface with this DAO, we need or we want to do that inside of our repository class. So if we go ahead and take a look at the documentation here, right? We've seen this before. This little diagram should be familiar to you. We have our activity or our fragment. We have the view model. All of our live data is in there connected to our repository. And in this case, we're actually going to use one of these little branches here. And instead of implementing anything with the network, we'll get to that in a little bit, we are going to go ahead and go this route where we are going to interact with Room, which is a wrapper around the SQLite database that has been around for quite a while now. So it's not the fragment's job to communicate to the database. It's not the view model's job to communicate to the database. It is the repository's job to communicate to the database, and the repository does so from an action from the view model, which ultimately stems from our activity or fragment level. Right, so if we were actually to try to fetch everything that's in our database, the flow would be the fragment request the view model will request our repository, then the repository will get all of the stuff, all of the items out of the database and just bubble things up again through the live data. So we can build this interaction layer here with the database. So we're going to go ahead and just kind of mimic this stuff here. So we have, I'll get to this in a second, but we have basically defined our three functions here that exist in our repository that basically allow us to interact with our data access object here, which will ultimately get things in and out of the database for us. You can see here in the repository constructor, we've now added a dependency essentially. So this to buy repository, in order for it to do the things that it needs to do, we need to actually provide it some information. And instead of providing the database on all of the different function calls that exist for this, that this repository supports and all of these, we're just going to go ahead and put it in the constructor so that we just have to set it once, and then we're going to go ahead and just use that database within the context of the functions. And so because we've created this basically this singleton instance here of the database, we should be able to just not have to worry about having multiple databases or anything along those lines. We should always have the same reference and the ability to always operate on the same database. So we have taken some precautions there. So this seems to be pretty ready here, this repository layer. So we're just going to go ahead and move this over here, and now we need to kind of think about the to buy view model level. Well, okay, so first we're going to have to define our repository. So our repository here needs this database at construction time. Unfortunately, because I don't want to get into building so although this might appear to work, the view model taking something as a parameter as in the constructor, it actually won't work at runtime because or even I don't even think at compile time, because of the way that we're actually going to get the view models. Remember, we don't actually instantiate a view model like we would any other object. We actually use this built-in factory system that Android has as part of the library for this architecture. So we don't actually have the ability to create a particular view model just on the fly here. And so in order for us to accomplish this, I guess just straightforward approach of defining the parameters within the constructor of the class. We would actually need to create our own factory and implement a whole bunch of things, and it would just get a little bit more confusing than I want it to be. So we're actually running into our very first issue here of dependency injection, really. So there are some libraries out there, Dagger and such is the most popular, to actually accomplish this, and for now we're going to actually avoid Dagger. However, we most definitely will likely change this over to a Dagger implementation to actually show, I guess, the pain points that a dependency injection library can help you out with. So for now, we're going to go ahead and try to figure this out without dependency injection, with the idea of coming back to it later to showcase the power, I guess, or the convenience that a dependency injection library provides to you. So we need a way to actually get an instance of this database inside this view model so that we can actually create our repository here. So the quickest way that I can think about this here is to create a late init variable for our repository and define an init function for our view model, and then inside the init function we're going to have to say repository equals 2by-repository with the app database. And then at this point we can actually maybe do some other interactions with the repository because it's all set up, but we now not only have to create or fetch our view model via the factory method, but we also now need to ensure that we call init before we do anything else with our view model, because our repository has not been initialized until we actually run this function. So we can do this for right now because it is a simple and straightforward approach, but just know that this isn't the best programming practice, because as things start to scale, or as you join larger projects, or as you add more dependencies, or have just more complicated applications to build and manage, you don't want to have to worry about something silly like this, where you have to make sure you do something in sequence so that everything isn't going to crash. So anyway, we can, with the Initialize Repository, go ahead and just kind of create a pretty similar structure here. Might as well just copy it, to be honest. And here we're just going to say repository insert item, item entity, and then this one is going to be delete item. So, you could argue, oh, what's the point of this? You shouldn't, we're just kind of duplicating code. You could just have this fragment interact with the repository. Well, this construction issue is one reason to avoid that, and then also it just breaks the architecture pattern. So we're going to avoid that for now as much as we can, or forever, because it's not what we should be doing. And then we're going to have our live data here of items. So let's call this item entity entities live data. It's going to be a mutable live data of a list of item entity. And this is going to be the outward-facing view model that our fragment is going to hook into and attach to, so that it can actually draw everything that's on the screen that's inside this list. Now that we have our item entities live data, we can actually, once we have initialized our repository, we can go ahead and make use of it. So if we were to get our items from our database, we'll call it items, equals repository, get all items. Excuse me, cat, come on, you're in my way. Thank you. So we can go ahead and post these items to our live data, just like that. So now when we go ahead and initialize our view model with the correct database, we will not only initialize our repository, but we will also initialize the initial fetch of the data that exists in the database at that moment in time, which will likely be, when the app opens. So very quickly, let's just go ahead and do that as well. Go ahead and just move this over here. So when the app opens, we want to initialize our view model that we're going to be using. That's going to be scoped at the activity level that the fragments are going to access. Initialize that immediately so that before anything else happens, we are already beginning to fetch the data. So we can go ahead and just say our view model of type 2 by view model by view models. We will get our view model, and then we can just say view model dot init with our app database, which we can call app database get database with context being this. So that should do it. Let's see if we implement our home fragment really quickly here. So we have our home fragment here. Pretty standard stuff here is basically the bare minimum boilerplate code you need for the view binding implementation. Again, if you are not familiar with that or have no idea what's going on right now, this is covered in a previous season, so you can definitely find some more content on it in earlier videos on the channel. So if you need to, please feel free to get caught up with that. But we have our home fragment here handling our correct binding for what we created earlier, which had the epoxy recycler view in it, and then just nulling things out when we should. We are implementing our base fragment, and previously we had something in place where we fetched basically, in order to get the view model at the activity level, we actually referenced the view model at the main activity. So we had like a global variable stored here for the view model, and then we reference that in the base fragment. However, there is a better way to do that. So we're going to go ahead and just create the shared view model variable here in our base class. It's going to be of type 2 by view model, and then we are going to get that by, nope, we don't need that. We are going to get it by activity view models, just like that. So much like here in the activity class, we are calling by view models, and it actually is an extension function on the activity, or an inline function here on the activity that the library has given us, which will basically just run the whole factory setup for that particular view model. And the fragment itself has the activity view models or just the view models extension or inline function there. And you can see here fragment.viewModels or fragment.activityViewModels. You can read through the documentation, but you can go ahead and see this whole factory producer and see under the hood how everything is working. And if you really want to take a deep dive into it, you can learn more about how to actually create your own factory, which we might get into at a later date, but not at this very moment. But basically know that there's a simple extension function here to either scope your view model to the activity or scope the view model to just the regular fragment. So I guess something to note here is that these are two completely different view models, and even though they are of the same type, they are going to be two different instances of the view model. They are going to have different data associated with them, and you can run into a whole bunch of issues where it's like, where's the data? I thought we were using this proper view model, but really at the end of the day, the difference here is where these view models are scoped. So when this fragment gets destroyed, this view model will also be destroyed. But when this view model, or when this fragment gets destroyed, the shared view model 2 in this case does not get destroyed because it is attached to the activity level. So we've talked about a bit about scoping before, so hopefully that's not news to you, but the activity view models is just a cleaner, faster, nicer, simpler way to go ahead and scope something to the activity level. So then inside of our home fragment here and any of our other fragments that we call or that we extend base fragment for, we will have our shared view model, which is going to just be the view model that exists across all of the fragment life cycles because it's scoped at a higher level. And here we can say item entities live data, observe view lifecycle owner, item entity list. And then we can go ahead and actually do things with this list here. So if we were to run it, all right, we seem to have run into a little bit of an error here. Haha! Cannot access database on a main thread since it may potentially lock the UI for a period of time. Okay, so I didn't realize that this was actually causing a crash, but this is probably a good time to cut the video because it is getting a little long. And in the next video, we are going to actually go ahead and handle this issue here of accessing, basically trying to do something on the main thread that could potentially be a long-running task, right? Imagine the database has 150,000 records in it, and it has to pull all those records into a list and then provide them to you. You could be waiting on the screen for seconds, and that would not be a very good experience for the user. So we're going to have a discussion about multi-threading, and I guess we are going to introduce the glorious Kotlin coroutines that basically will make this a very straightforward task and is a wonderful solution to multi-threading. So I hate to leave you on a cliffhanger here, but I am excited to see you in the next one where we will introduce Kotlin coroutines. Thanks.